The skin is a physical barrier that prevents entry of pathogens. However, when the skin is broken, pathogens may enter at the site of a cut or wound. In addition, cilia are fine hairs that line the windpipe that move mucus and trapped particles, such as pathogens, away from the lungs. Pathogens enter causing mast cells to release histamine, which attracts leukocytes such as phagocytes, dendritic cells, and lymphocytes, as well as releasing cytokines, interferons, and interleukins. Cytokines stimulate production of proteins, whilst interferons slow down the speed of damage by alerting healthy cells, and interleukins regulate cell growth. Histamine also causes blood vessels to expand and allows macrophages and dendritic cells to move to the site of infection. Meanwhile, neutrophils engulf pathogens that self-destruct and become pus. Macrophages and dendritic cells engulf pathogens and will show these on their MHC2 markers as they are antigen-presenting cells. Complement proteins work to opsonize pathogens by attaching proteins to foreign invaders so they are more readily identifiable to phagocytes. They also release signals to phagocytes acting as chemoattractants, as well as destroying membranes by creating pores in the pathogen known as the membrane attack complex, or MAC, leading to the lysis or necrosis of the cell. Pathogens are detected by phagocytes and are then engulfed to form a phagosome. The phagosome binds to a lysosome that contains digestive enzymes forming a phagolysosome. This will break down the pathogen until there is just indigestible material. The leftover materials will then be discharged from the phagocyte. If it is an antigen-presenting cell like a macrophage or dendritic cell, they will present the foreign antigen to a helper T cell to activate the adaptive immune response. APCs phagocytose antigens from infective agents and present them on their MHC2 markers. They then migrate in lymph fluid to the lymph nodes via lymphatic vessels where helper T cells recognize and bind to the APCs. The helper T cells become activated, causing them to proliferate and differentiate into active helper T cells, including some memory T cells that remember the antigen. Meanwhile, B cells recognize specific free antigens floating around via their membrane-bound receptors. They then engulf the antigen and present them on their MHC2 markers. The B cells present the antigens to previously activated T cells, causing it to release cytokines to B cells that cause clonal selection, and they will proliferate and differentiate into plasma cells and memory B cells, leading to clonal expansion. Plasma B cells then release antibodies specific to the antigen. Antibodies have a Y shape with heavy chains at the bottom and light chains at the top. The constant region does not change, whereas the variable region is what is specific to bind to an antigen. Infected cells will present antigens on their MHC1 markers. Cytotoxic T cells bind to the antigen, and with the help of cytokines released by helper T cells, is when clonal selection occurs and they proliferate and differentiate into active cytotoxic T cells and memory T cells, which is clonal expansion. Active cytotoxic T cells recognize infected cells and secrete perforin, which punches holes in the cell membrane. Granzymes are also released, which activate apoptosis in the cell, causing the cell to shrink, bleb, and form apoptotic bodies, which is then phagocytosed by phagocytes. Alternatively, cytotoxic or natural killer cells use their Phas signaling molecule to bind to death receptors to initiate apoptosis.